Alright, I'm going to start with number 5 because the front page was pretty good for you guys. So I'm going to start with number 5 on the back. So with this one, we have e to the second times e to the eighth. So we're multiplying two powers that have the same base. All we have to do here is add the exponents. So this is e to the 10th. For number 6, we're going to be adding exponents again because we're multiplying powers of e. But first we need to take care of this, this squared. So let's take care of that thing first. So we have e to the negative 3x raised to the second. So using our exponent rules, we're going to multiply those exponents together. We get e to the negative 6x. And then we have e to the 2x times e to the negative 6x. Well, we could flip that e to the negative 6x down to the bottom of the fraction first. But I think let's just go ahead and add the exponents together. Multiple ways to do this, but you should end up with the same answer. So then this will give you e to the negative 4x. Now actually a lot of you left it just like this, but remember I always want you to give answers with positive exponents. So let's flip that down to the bottom. And that's it. Alright, the log of 100. So remember that if there is no number for the base, it's implied that it's a 10. So this is asking you what power do you have to raise 10 to get 100? And that power is 2. 10 to the second is 100. Number 8, this is log base 6 of 216. So it's asking you what power do you have to raise 6 to get 216? And it's 6 to the third is 216. Log base 3 of 5, so this is asking you what power do you have to raise 3 to get 5. Now this is going to be a fractional exponent or a decimal, and so there's no good way to do this kind of intuitively, so you're going to have to plug it into your calculator. And to do that, you're going to have to use the change of base formula. So we'll say the log of 5 divided by the log of 3, that's equal to, 3, not 5, that's equal to the log base 3 of 5. So put that into your calculator and you should get about 1.46 approximately. It should be noted that you could also use the natural log. So you could say natural log of 5 divided by the natural log of 3. That would also work. You should get the same answer. Either way is fine. Remember that exponents and logarithms are inverse operations, meaning they undo each other. So if you have 6 raised to the log base 6, that will cancel out, and you will just be left with what's in the logarithm. So this is just equal to 8. Here we have the log base 4 of 16 to the x. Well, this is going to be very similar to the last problem, except we need to have 4 to some power. So again, logarithms and exponents cancel each other out. And so what we need to do is make that 16 be written as 4 to some power. So 16 we can write as 4 squared. We have 16 raised to the x, so we have 4 squared raised to the x. Okay. Using the exponent rules then we can say this is the log base 4 of 4 raised to the 2 times x. So then we have the log base 4 of 4 raised to some power. So the log and the base cancel each other out, and we're just left with 2x. For this one, a lot of you guys were trying to write this, do something like that. So that's the right idea of bringing the exponent down out front and multiplying, but you can only do that if you have the entire thing inside the logarithm raised to that power. So 14 is not raised to the third power. So we need to separate these logarithms. We need to expand them first, and then we can pull down the exponent. So using the logarithm rules, this is the natural log of 14 plus the natural log of x cubed. So remember the reason why this is because logarithms are giving you exponents. And so if we have two things multiplied together, this is 14 times x cubed, what we would do with those exponents is add them together. And so we're going to add the logarithms together because the logarithms give you the exponents. All right, so then we're going to take that 3, pull it down, and we get the fully expanded form of logarithm, natural log of 14 plus 3 times the natural log of x. That is the fully expanded form. For number 13, the first thing you want to do is reduce that fraction. If you don't reduce that fraction, I gave most of the credit at 3 of the 4 points if you did have the fully expanded form without having reduced it first. But the first thing we want to do here is definitely reduce that fraction. So we're going to have this be x to the 4th over 2y, and that's what we're taking the logarithm of. And now, again, using these logarithm rules, since we have division here, when you divide things, you subtract exponents. So we can write this as the logarithms being subtracted. So we have x to the 4th, and then we have minus the log base 5 of 2, and then also minus the log base 5 of y. So both of those are subtracted because they're on the bottom of the fraction. And so anything that's on the bottom of a fraction, you can think of that as having a negative exponent if it were to be on the top. And so we subtract both of those. There's one more thing we can do, and that's going to be to take this, this x to the 4th and get rid of that 4th and put it out front. So we have 4 times the log base 5 of x. And that is the fully expanded form. For number 14, we're going to be just going the opposite direction as what we did for 12 and 13. So we're going to be combining this all together. The first thing that you have to do is take this 3 and bring it up as an exponent here. Now you have to be very careful because you have to raise the entire thing here to the 3rd power. A lot of you guys only raised x to the 3rd power. You have to raise the entire thing to the 3rd power. So this is the log base 3 of 2x plus the log base 3 of 4 to the 3rd power is 64, and then x cubed. And now we can multiply the insides together there. So again, we have logarithms added together, which means in order to add exponents, you need to multiply the things together. And again, logarithms give you the exponents. So we're adding exponents here. This addition here tells you that we're adding exponents. And so we got to multiply the insides of the log together. So the log base 3 of, we have 2x times 64x cubed. Now some of you got there but just left it like that. You definitely want to simplify this all the way. Answers in math should always be simplified as far as you can go. So this is going to be 128x to the 4th. And that is the fully condensed logarithm. Number 15. All right. So again, we have a number out front here that we want to bring up and make an exponent on the 2y. Again, make sure you raise both 2 and y to the 2nd power. A lot of you guys missed that. So we have minus the log of, then it's going to be 4y squared. And we have the log of 72x over here. Now since we're subtracting the logarithms, we're subtracting exponents because again, logarithms give you exponents. So if you're subtracting logarithms, you're subtracting exponents. In order to subtract exponents, you're going to have to divide. So we get then 4y squared on the bottom, and then we have the log of that. And then we can reduce the fraction. So we can say this is the log of, 72 divided by 4 is 18. So we get 18x over y squared. That is the fully condensed logarithm. 16 says solve by equating exponents. So if you look at this equation carefully, you'll notice that we have a 3 raised to some power and 3 raised to some power. So in order for the left side to be equal to the right side, the exponents here have to be equal to each other. There's no other way that we can have an equal sign here unless this exponent is equal to this exponent. That's the only way this equation can be equal. So that means we can just take those exponents and set them equal because we know they have to be equal. And then solve this equation as you normally would. So subtract 3x and we get x plus 8 and negative 5. Subtract 8, and we get negative 13. Number 17, again, we need to equate exponents. However, this time we don't just have something raised to a power and then that the same base on the right side like we had for number 16, where we had 3 to some power and 3 to some power. We have different things here. However, both of these can be written as 3 to some power. So we can write 9 as 3 squared. So we have 3 squared raised to the x plus 2. And 1 over 27 can be written as 3 to the negative 3. So we have 3 to the negative 3 to the x plus 12. And then we can use our exponent rules here. So we take 2 and multiply it by x plus 2. Make sure to distribute. We get 2x plus 4 as the exponent. And then on the right side, again, distribute the negative 3. And we get 3 raised to the negative 3x minus 36. And now we have something that looks similar to the last problem. So we can equate the exponents. 2x plus 4 equals negative 3x minus 36. Solve that equation, and you should end up with x equals negative 8. Number 18. All right, we have the log base 2 of x plus 8 equals 4. So in order to undo that logarithm, we need to raise it as an exponent on 2. So a log base 2 and 2 to some power, that cancels out. So what we're going to do is we're just going to raise both sides as exponents on 2. So we're going to have 2 raised to the left side of the equation and 2 raised to the right side of the equation. I know that's kind of a weird thing to do, but remember that we can do anything we want to an equation. As long as we do the same thing to both sides, we can do anything we want. So we can just make each side of the equation an exponent on 2. So then on the left side, the log base 2, or 2 raised to the log base 2, cancels out, and we get x plus 8. Then on the right side, be very careful here, this is not 2 times 4, it's 2 raised to the 4th, which means 2 times itself 4 times, which gives you 16. So then solve this and you get x equals 8. And the last one. This one was the most problematic one on the test, so we definitely need to talk about this. So the first thing to talk about is that you cannot just raise each of those as exponents on 6. You cannot do that. Again, if you're going to do something, so you can do anything to an equation as long as you do the same thing to both sides, but that's not what I just did here. So we can't just dive inside the equation and just put 6's here wherever we want. We would have to do, if we were going to do that, we would have to raise the entire left side. So we would have to take this whole thing and do 6 raised to that entire thing. And that's not going to be super helpful to us, at least not right now. So we will do something like that in a moment. But the first thing we need to do is condense this logarithm. So we have the logarithms added together, which means we can condense them into one where we multiply these together. And then if we use the distributive property, we get x squared plus 16x equals 2. Oh, and the log base 6 of that. Okay, and now that we have just the one logarithm on one side of the equation, now we can take 6 raised to each side. So then we get x squared plus 16x on the left. And again, this is not 6 times 2, it's 6 raised to the second, which is going to be 36. Subtract 36 from both sides. Again, the reason we do that is because the only way that we have of solving quadratics right now is if we have 0 on one side of the equation. So then you can take that, and you can either factor or you can use the quadratic formula. Either way will be just fine. And you should get x equals negative 18 and x equals 2. Now, one of those is an extraneous solution, meaning it's a solution that looks like it is a solution but isn't actually. And so what you want to do is plug those back into the original equation and see what you get. And so if we do that, I'll tell you that 2 is the real solution, or is the actual solution. Negative 18 is not. And the reason for that is if you take negative 18 and plug it in here for x, so we have the log base 6 of negative 18. So that's asking you, what power do you need to raise 6 to get negative 18? Well, that's not possible. So if we're raising 6 to some power, we're multiplying 6 by itself, and 6 is a positive number. And there's no way that you can multiply positive numbers together to get a negative number. So it is impossible to do the log base 6 of negative 18. So that tells you that negative 18 is the extraneous solution. So we throw that out, and we get get x equals 2 as the answer.